All right, good morning, everybody. We're going to be going over the important ideas and summarizing just what we did for our 4 steps for a chi-squared test for goodness of fit. So remember, you got to do your state, which means you need your null and alternative hypothesis. Remember, that's where you say your claimed distribution was true in context, and then you'd say the claimed distribution is not true for your alternative. And then you also need to state your alpha. And as long as you put context in your null and alternative hypothesis, stating your parameter isn't necessarily necessary. For your plan piece, there's 2 checks. First one that you always have to have for every test is either random assignment or random sample. The second one in this case is that all of your expected counts, remember it's got to be your expected counts, are greater than or equal to 5. Remember, your expected counts is equal to the sample size times those individual probabilities, right? And then for the do piece, in this case, it's a chi-squared goodness of fit test. You're trying to see how well does your distribution, your sample distribution, fit the overall distribution. So that's why it's called goodness of fit. So then once you do that, you've got to plug in your observed into L1, your expected into L2. When you run this test in your calculator, you also need your degrees of freedom. Remember, that's number of categories minus 1. And then you also need, once you're done, you need to spit out what's your test statistic and what's your p-value. And then for your conclusion, same thing as usual. You got to compare p to alpha, reject or fail to reject. The null, and then give your context. So we have our 4 steps. Other big ideas are just what does the chi-squared test distribution look like? We sort of talked about this on the other page, but your chi-squared distribution always is going to start at 0 because you can't have a squared difference be less than 0 because you're squaring everything. And when you do that, your chi-squared test says, what are the chances that your differences are, however big or more extreme, would always be larger? So it always starts at 0. And it will always be skewed right. So this is not, when you're describing the shape, this is not a normality check. This is to see if we can use our chi-squared check. So that's why I didn't say normality for our plan piece there. For your check, your understanding, this is talking about, does the warm, sunny weather in Arizona affect the driver's choice of car color? I think this is interesting. So, excuse me, that was my water. We're going to, once again, look at this situation. We have all of this data. Tricky part is, once again, these are my true proportions of my sample. So these are my observed. My expected counts, I would have to take all of these percentages and multiply them by 300 to get my expected counts. Right, so we're going to take all these percentages and multiply them by 300 to get my expected counts, right? when I do that, I'm not sure where we want to write that or not, but you can go ahead and put that into L1, L2. I'll just help you guys with your null and alternative hypotheses. Your null hypothesis is always the distribution of car color. We're going to assume is the same. In Oro Valley as North America. And then we're hoping to say the distribution is different. So once again, we're either true, meaning the same as North America, or we're not true. Don't forget to state your alpha of 0.05 in the very beginning. They don't give us an alpha, so we have to use an alpha of 0.05. Then when we do our name our procedure, remember if you do this below, it's not necessary, but we do need to check our conditions. The first one is random. I see up here that she selected a random sample of 300 cars. So that's given. And then for step 2, are all of our expected counts big enough? So once again, our lowest expected count is that 0.02 times 300, and that was for your green. In that case, you're going to get 6. So your lowest expected count is bigger than 5, which means all expected counts are greater than or equal to 5. So we can continue with our chi-squared test. Remember, we can talk about our formula. You don't necessarily need to do this by hand. So we have our observed minus our expected squared over our expected. Then we have to take the sum of all of those things. Our picture, once again, it's not necessary, but it's helpful just to get a good picture of what's going on, right? And then our value or more extreme. And our distribution, our chi-squared distribution, is based on degrees of freedom, which in this case, number of colors minus 1 is 7. Our work, though, remember, when we do our chi-squared goodness of fit test, we're going to say our observed is in L1, our expected is in L2, our degrees of freedom is 7. And then once you have all of your expected counts, you calculated those, you can spit out your test statistic and your p-value. Our test statistic is pretty large. It's 29.92. And then our p-value is 9.8 times 10 to the negative 5th. Remember, I actually do want to see you guys move the decimal over. So once again, your conclusion, you take your p-value, compare it, oops, it should be less than alpha. If you are less than alpha, you can reject the null hypothesis and can say Oro Valley has different car color distribution. And then this last question is asking you, is there convincing evidence of a difference in the distribution of car follow, or if there is convincing evidence of a difference of distribution in car color, perform a follow-up analysis. What this means is like, what had the biggest impact on us being able to reject the null hypothesis, right? And if we do that, we would say we were able to prove yes, or in other words, reject H sub 0 because the other category was very different. Okay. And remember, that came from your contributions. If you look at your calculator when it spits out a whole bunch of those numbers, if you write them down, you'll see the contributions of each one of those categories, and that's where that is very helpful. But otherwise, you guys can go ahead and work on your 11.1 quiz, and then check your answers in pen, please, and then upload, excuse me, and then upload your solutions with your answers checked in pen. All right, thank you.